All right, folks, hope you guys are doing well on this Monday morning. Sorry I couldn't be here, but basically what I want you to do is I want you to complete this document. Um, Obviously, if you guys are in the classroom, hopefully you can get a paper copy. If you guys are down in the auditorium, unfortunately, you're going to have to do this online. So, either way, basically, we took the quiz on Friday. Plan is we're going to continue this slope stuff and close it out by the end of next week, or by the end of this week, actually. Sorry. By Friday, we'll take the test and we'll be done with this chapter. So we're going to continue to look at slope. And if you remember on the on the quiz that you guys took on Friday, you guys had scatter plot stuff and you had slope stuff. And today, this activity is going to combine them. And I'm hoping you guys will be able to figure it out, all right? So let's read through this problem. I'm not going to give you the answers to this. I'm going to need you to fill this out on your own and turn this in to me. And so basically what this is saying is this. There's this person who's biking long distances, I guess as part of a triathlon. It says to prepare for biking long distances, he's going to track his, he's trying to ride at a steady pace, but there's so many hills that he's probably going to go faster and slower through different parts. And he's going to track his distance and time as he trains. He purchased a special watch. Think of an Apple Watch. Probably does something like this, where he's going to push a button and it's going to record data based on his time and how far away from his starting point is. And so at the end of the workout, the data comes out, and here's the data down here in the table. Okay. And so question A is asking, on his bike ride around town, he recorded several different times. And you can see, let me zoom in a little bit here. That's a lot. But what you can see is, move this. What you can see is like at 3 minutes away from, let's say he started at his house. 3 minutes away, he was half a mile from his house. Okay. At 5 minutes, he was a mile from his house. And then at 8 minutes, 2 miles, so on and so forth. Okay. So it's just tracking his data, how far he is at certain times. Okay. So according to the table, the question is, does he appear to be traveling at a constant rate? So think about what a constant rate means. It means that as he travels, say every minute, for example, every minute he would travel the same amount of distance. So like, for example, a constant rate would be every minute he travels, half a mile. Every minute he travels half a mile. Or every minute he travels 3 miles. But every time, 1 minute would be 3 miles, 2 minutes would be 6, so on and so forth. Constant rate. The way to check that is, let's look at the table. And let's look. Now, I'm not going to give you the answer here. I want you to answer this, but just look at from 3 minutes to 5 minutes. That was 2 minutes, right? From 3 to 5. In 2 minutes, how far did he travel? And, look at the distance. He went from 0.5 to 1 mile. So in those 2 minutes, he traveled a half a mile. So now if that pattern continues, then yeah, he's traveling at a constant rate. Let's check the next interval here. It says in 3 minutes, from 5 to 8, in 3 minutes he traveled 1 mile. So now something kind of doesn't seem right there. 2 minutes, half a mile. 3 minutes, 1 mile. Already that's not really working, right? Check another one. You can check a couple of these and see if any of these match up. 8 to 12 is 4. So in 4 minutes, he traveled 1 mile. Now, wait a minute. It took him 3 minutes to travel a mile here, but then in 4 minutes, he traveled a mile. So right there, that's kind of telling you your answer is this a constant rate or not? Well, these don't appear to be the same. So I'm going to leave that one up to you, okay, to determine whether that's a constant rate. But the way to check that is just to see. In 2 minutes, he went half a mile. In 3 minutes, he went a mile. And then in 4 minutes, he went a mile. Those don't really match up, so I'm going to leave that one up to you, but type an answer for A, all right? For B, graph the data. Those of you online, I believe you can go in here and graph the data. Look at that. That's already there for you. It's awesome. The table's in there. I didn't even know that. So graph this data. Best you can, plot points, graph the data, all right? Another way you can check is if you can't figure out A, if you can't figure out if it's a constant rate. If your graph is linear, it's a constant rate. If your graph is kind of scattered and all over the place, it's not constant, okay? So graph it, and it asks you what type of graph is this. If it's linear, if it creates a straight line, great. If it doesn't, it's not linear. It would just be a scatter plot probably, okay? That's going to be up to you to decide. You'll plot the points. If it looks like a straight line, it's a straight line. If it looks a little scattered, it's a scatter plot, all right? All right, question C says draw a trend line. Now, if your data happens to be linear, that trend line will hit all the points. But if it's a scatter plot, just draw a trend line and use it to make a prediction, okay? So after you plot your points, you're going to go back in to your graph and create a straight line. However your data is, I'm not going to graph the data for you, but you're going to hit this line tool and just create a straight line for your data, a trend line, okay? And use that to predict how far he'll be after, or actually it says how long it'll take him to drive 10 miles. So, you know, whatever your trend line looks like, you're going to go to 10 miles and just follow it out, find the point, and figure out how long it'll take him, all right? So use that trend line to make a prediction. And then part D, what is his general rate? You drew a line, and so you can find the slope of that line however you need to. So draw whatever your trend line is. Let's say, for example, this is my trend line. I can use it to make a prediction. For example, you know, if this was my trend line at 10 miles, it would have taken him 30 minutes, that point right there. Okay, to find the slope, you would just do what you normally do. Even though there's all these, you know, if it's a scatter plot, even though there's all these points here, you would still just pick, you know, here's a point. And this is not exact, so don't copy this. And here's a point, and you just count. You know, it looks like it's going up by half. So 1, 2, up 2, and then over. It's like it's going by 2s, so over 2, 4, 6. So up 2 over 6, 2 over 6 would be my slope, right? All right, other than that, plot this data, draw the trend line, find the slope. That's all you're going to do. Part B, plot the data. Part C, draw a trend line. And D, find the slope of the line that you draw, okay? All right, ladies and gentlemen, do your best. You do need to have something down. This needs to be turned in. If I'm going to be gone, you got to show me something. You got to do something, okay? So please make sure this is complete. Do the best you can. Write sentences if it asks you a question, and you know, graph the data, and have a graph ready to go, okay? Answer the questions to the best of your ability. All right, ladies and gentlemen, take care. I'll see you guys on Tuesday. I will be back. Have a fantastic rest of your day. All right.